In this video, we will cover how to write equations of a line given the slope and y-intercept. When we are being asked to write an equation of a line, there are three formulas that we must keep in mind. Depending on what we are given will be the formula that we will use. So the formulas are the slope formula that states that m is equal to y2 minus y1 over x2 minus x1, and x1, y1, and x2, y2 are points. Then the slope-intercept form, y is equal to mx plus b, where m represents the slope and b represents the y-intercept. And then finally, the point-slope form that reads y minus y1 is equal to m parentheses x minus x1, where m still represents the slope and x1, y1, it's a point. Now with this in mind, let's complete example 1. In example 1, they're asking us to write the equation of a line given the slope and the y-intercept. Then the formula that we're going to use will be the one that is named slope-intercept. So let's bring it down. Y equals mx plus b. Now remember that m represents the slope and b represents the y-intercept. So then we replace this. This becomes y is equal to negative 6x plus 4. And this is an equation. You have found the equation of the line. This equation is in slope-intercept form. Now, from time to time, you're going to be asked to change this equation from slope-intercept form into standard form. Now, the standard form was seen in the video for finding slope, but let's write it here again. Now, the standard form is ax plus by is equal to c. Now, there are two requirements for the standard form. Let me write the name at the top. The two requirements are that A, B, and C have to be whole numbers, and that A is positive. So what we're going to do now is we're going to take the slope-intercept form and we're going to rewrite it in standard form. Now notice how in the standard form, x and y are both on the left of the equal sign, and in the slope-intercept form, y is on the left, but x is not on the left. X is on the right side. So I'm going to have to move that x to the left side. Since x is minus 6x, we're going to move it by adding. We're going to do the opposite or the inverse operation. So on the left side, I cannot combine these two terms. They're not like terms. One is an x and one is a y. Now, it doesn't really matter which one you write first, but because the standard form says that it wants x is first and y second, we'll write that. We'll write x is first and y second. So this is a positive 6x, and then that was a positive y in there. Don't lose the equal sign. On the right side, minus 6 plus 6. Since they have different signs, we're going to subtract. So 6 minus 6 will go to 0, leaving us only with that 4. And then we check, do I have the x's and the y's on the left side? And we do. Are a, b, and c whole numbers? Yes, we don't have any fractions. And is a positive? Yes, this is a positive 6. Then this is also the equation of the line, but this time is in standard form. Now, do understand that these two equations represent the same line. It's just that this one is written in slope-intercept form and this one is written in standard form. Let's move on then to another example. In example 2, we're still given the slope and the y-intercept. So we're going to continue to use the slope-intercept form. Let's bring it down. Y is equal mx plus b. And m represents the slope, which we are given, and b represents the y-intercept. So all we do is replace those variables with the numbers. So then this becomes 3, 4, don't lose the x, plus that 1. And you are done. You have found the equation of the line in slope-intercept form. Okay, but we're going to try it again. We're going to try to write this equation again as a standard form. Remember, A, B, and C have to be whole numbers, and A has to be a positive to meet the requirements for standard form. So then we bring the equation that we just got in slope-intercept form, and we're going to try to write it in standard form. Now, the very first thing I'm going to notice is that there is a fraction here. Since we are not allowed to have fractions, we're supposed to have whole numbers. I'm going to get rid of that fraction. If you want to eliminate fractions, all you have to do is multiply by that denominator in the fraction. That means that every single term will get multiplied by 4. Okay, from left to right, 4 times y will just be 4y. Don't lose the equal sign. On the right side, however, let me do it on the side. When you multiply a fraction times a whole number, the different ways that you can do that. We can place a 1 under. A whole number becomes a fraction by dividing by 1, and then we multiply across. So then this becomes 12 over 4, but 12 over 4 can be simplified into 3. So then this becomes 3x. Now I'm going to show you another method. If you multiply a fraction times a whole number, you can always do the following. This is a shortcut if you want to see it like that. You multiply the numerator and then divide the denominator. So 4 times 3 will be 12. 12 divided by 4 will be 3. You get back the same value as before. Now, there is a property of algebra also that states that when you multiply a whole number or a variable times its reciprocal, which these two are, they will cancel out each other, leaving you only with whatever value is in the numerator. So whichever method you want to remember is up to you. Just remember that the only time that these two, well, if you want to see it as canceling, is when they are the same. Okay, so now that I have multiplied the fraction times 4 and it gave me a whole number, I still have to multiply this last term. So 1 times 4 will be 4. All right, so then we have whole numbers. However, remember that the standard form has to have x and y on the left side. So I'm going to have to move this 3x to the left side. Since it's a positive 3x, I'm going to subtract 3x. Remember, we cannot combine these two terms. They're not like terms, but we write them in alphabetical order like they want it in standard form. So this becomes minus 3x, the positive 4y that was there, equals, on the right side, well, 3 minus 3 will go to 0, plus the 4. However, this time, we seem to have a little problem. Although x and y's are on the left side, a, b, and c are whole numbers. A is not a positive value. You see how a is a minus 3? So what we're going to do, anytime that this happens, that your a is not positive, what we're going to do is we're going to multiply every single term by -1. What you do to one side, you have to do to the other. And let's see what happens. 1 times 3 is 3, but the negative will become a positive. And then 4 times 1 is 4, but the positive negative, they have different signs. That will be -4. Don't lose a y. And on the right side, 4 times that -1 will be another -4. So we check. X's and Y's are on the left. A, B, and C are whole numbers, and A is a positive. Then we have found the equation of the same line, but now in standard form. Now you might be asking, do you always have to do both? When do I stop? Well, if they don't specify, all you have to do is find the slope-intercept form, this first one that you found. The only time that you continue to these steps is if they ask you to find the standard form. Let's try just one more example in this section before we move on to the next section. In example 3, we're still being asked to write the equation of a line given the slope and y-intercept, but I don't see any m's or b's written in here. However, they say that they are given as a slope and the y-intercept. Well, the reason why they're saying that is because I can get the slope and the y-intercept from this graph. So for example, the y-intercept is where the graph crosses the y-axis. So the graph is crossing the y-axis right here at 1. That means that the y-intercept, or b, is equal to 1. So it is given to us. Now, the next thing, I can find the slope by using rise over run. So what I need is to find a second point in this graph so that I can do rise over run. Now I'm going to use this point right here. I'm going to use this one. This is 3, -1. I hope that you can see the lines right here on the graph, and that's why I chose this one, because it's right at the corner of 3 and -1. So the way that we find the slope, remember, is by doing rise over run, and we move from the left to the right. That means that I'm going to move from this point to this point, from left to right. So we're going to measure the rise first. In this case, I'm going to move 1 in, 2. Since I moved 2 down, the rise is going to be -2. And then I look for the run. So I'm going to move 1 and 2 and 3 on the run. Since I moved to the right, the run will be 3. So now I have the slope right here and the y-intercept. Then I'm ready to write my equation in y equals mx plus b by replacing m with -2/3, don't lose the x, and the b with that +1. So I found the equation of this line given the graph in slope-intercept form. Now, if they ask you to change into standard form, then just go look back at example 1 and 2 so that you can go from slope-intercept to standard form. Thank you so much for watching, and I'll see you in the next one.